Scientific Method Applies to Chemical Engineering by Muriel Michael. What is the scientific method? Though this method was first refined centuries ago, it is a tool that is still in use today by scientists, professionals, and by any inquisitive person looking for a logical answer to the world around them. The scientific method, as used by chemical engineers, is a 7-step process. Step 1. Ask a question. The genesis of the scientific method comes from observing the world and forming a question from your observations. Why does water seem to take longer to boil when salted than when not? Do background research. Doing background research enables scientists to formulate plans on how to test the questions they have come up with. The USGS Water Science School states that water boils at 212 degrees Fahrenheit in normal conditions. Step 3. Construct a hypothesis. Constructing a hypothesis means creating an educated guess about the information already gathered in regards to the original question. A hypothesis needs to be able to be testable in order for it to be useful. Example, if normal water boils at 212 degrees Fahrenheit, then adding salt to the water should change the temperature at which water boils. Step 4. Test with an experiment. Next, the experiment should be created from the information gathered during the research phase about the question from the beginning of this process. Example, this experiment will test the boiling temperature of 300 milliliters of water in a saucepan as measured by a thermometer. This first test is the control group. The second test will be 300 ml of water with 10 ml of salt in a saucepan, heated to boiling with the temperature of the boiling point determined by a thermometer. Step 5. Is the procedure working? Before and even during an experiment, it is important to troubleshoot the procedure being used to determine whether or not it will be actually answering the hypothesis. To test whether or not salt changes the temperature at water boils, we will be using the same tools and heat source to boil unsalted water as the salted water. This eliminates variables in the heat source and heat conductivity of the container holding the fluid. Additionally, using the same thermometer can prevent variables between measuring tools. Lastly, the same volume of water will be used for the salted and unsalted water, and the base water for the salted water will be from the same source. Step 6. Analyze data and draw conclusions. When the experiment has been completed, all data that has been collected from the experiment and research should be gathered together and analyzed to see whether or not the data supports the given hypothesis. Example, data collected shows unsalted water boils at 212 degrees Fahrenheit, whereas salted boils at 216. This shows that the addition of salt to water changes the chemical composition enough to make the boiling point higher. Step 7. Communicate the results. For many scientists and chemical engineers, the next step can be for them to formalize the results of the hypothesis in the following experiment into a report that can be submitted to scientific journals and reviewed by peers for accuracy. In day-to-day life, however, communication can be as simple as sharing ideas verbally with your social circles. Conclusion. The scientific method is a useful tool utilized not only by scientists but also by many people in their daily lives. It is such a universal tool that it is used in hard sciences like chemical engineering and soft sciences as psychology, as well as within the normal functions of day-to-day life.